80 millimeters of sloped armor, 75 millimeters high-velocity gun, 45 tons of German precision engineering, 45 millimeters of sloped armor, 76 millimeters gun, 26 tons of Soviet mass production. Kursk, July 1943. The largest tank battle in history. 6,000 tanks colliding on the Russian steppe. German Panthers facing Soviet T-34s. Germany's newest weapon against the Soviet tank that had shocked the Wehrmacht 2 years earlier. Why did Germany rush the Panther into combat before it was ready? Why did the Soviets bet everything on the T-34? The answer is engineering philosophy, battlefield mathematics, and industrial desperation. This is the story of two tanks that defined the Eastern Front. And why the tank that broke down less won more battles than the tank that performed better. The T-34 medium tank entered Soviet service in 1940 and immediately changed everything German military planners thought they knew about armored warfare. When Wehrmacht forces invaded the Soviet Union in June 1941, German tank commanders expected to face obsolete Soviet armor that could be easily destroyed by German Panzer III and Panzer IV tanks. Instead, they encountered the T-34 and were shocked by what they found. The T-34's sloped armor deflected German anti-tank rounds that should have penetrated easily. The 76 millimeter main gun could destroy any German tank from ranges where German guns were ineffective. The wide tracks gave the T-34 mobility in mud and snow that German tanks could not match. German tank crews reported encountering Soviet tanks that seemed impervious to their weapons, while German tanks burned from T-34 fire. Field Marshal von Kleist would later write that the T-34 was the finest tank in the world in 1941, an admission that stunned German military leadership who had believed their panzers were superior to anything the Soviets could produce. The T-34's revolutionary design came from Soviet engineer Mikhail Koshkin, who understood that tank design required balancing 4 competing factors: firepower, armor protection, mobility, and mechanical reliability. Western tank designers typically optimized 1 or 2 factors at the expense of others. British tanks had good armor but were slow. American tanks were reliable but undergunned. German tanks had excellent guns but were mechanically complex. Koshkin's genius was creating a design that achieved acceptable performance in all 4 categories simultaneously, while remaining simple enough for Soviet factories to mass produce and Soviet crews to operate and maintain with minimal training. The T-34's sloped armor was the key innovation. Instead of using thick vertical armor plates like Western tanks, Koshkin specified thinner armor set at steep angles. A 45 millimeter armor plate angled at 60 degrees provided equivalent protection to 90 millimeters of vertical armor, because incoming shells would deflect off the sloped surface, rather than penetrating. This meant the T-34 could be lighter and faster than Western tanks while providing superior protection. The engineering was brilliant in its simplicity. The T-34 Model 1941 specifications demonstrated the effectiveness of Koshkin's design philosophy. The tank weighed 26 tons, significantly lighter than comparable Western medium tanks. The hull armor was 45 millimeters thick on the front, but set at 60-degree angles, providing effective protection equivalent to much thicker vertical armor. The turret was cast steel rather than welded plate, which was faster to manufacture, and had no weak points at weld seams. The main armament was a 76 millimeter F-34 gun that could penetrate any German tank in service in 1941 from normal combat ranges. The engine was a V2 diesel producing 500 horsepower, giving the T-34 a power-to-weight ratio superior to most German tanks. The wide 500 millimeter tracks distributed the tank's weight over a large surface area, allowing the T-34 to traverse mud, snow, and soft ground that would immobilize narrower-tracked German tanks. Soviet tankers in 1941 and 1942 had an enormous advantage in this machine, but they often could not exploit it due to poor training, inadequate tactics, and incompetent leadership that resulted from Stalin's purges of the Soviet officer corps in the late 1930s. Soviet factories produced T-34s in staggering numbers that Germany could never match. The T-34 was specifically designed for mass production using relatively unskilled labor. The sloped armor meant fewer parts to manufacture. The cast turret eliminated complex welding. The diesel engine was simpler than gasoline engines and used fuel that was less flammable. Soviet factory workers, many of them women and teenagers with no manufacturing experience, could be trained to build T-34 components in weeks. Entire factories were relocated eastward ahead of German advances in 1941, reassembled beyond the Ural Mountains, and resumed production within months. By 1942, Soviet factories were producing over 1,000 T-34s per month. By 1943, production exceeded 1,200 per month. Total T-34 production during World War II reached over 84,000 tanks, more than any other tank model in history. This production achievement was possible only because the T-34 was designed from the beginning to be manufactured quickly by workers with minimal skills, using basic tools. German tanks required skilled craftsmen and precision machinery. Soviet tanks required determination and industrial capacity. But the T-34 had critical weaknesses that German forces learned to exploit. The crew compartment was cramped and poorly designed. The commander had to operate the gun because there was no dedicated gunner position in early models, meaning the commander could not effectively command the tank while also fighting it. The vision devices were inadequate, giving Soviet tank crews poor situational awareness compared to German tanks with superior optics. The transmission was crude and broke frequently, though it could be repaired quickly by crews with minimal training. The lack of radios in most T-34s meant Soviet tank units communicated through flag signals, making coordinated tactical maneuvers nearly impossible. German tank units with radio communication could coordinate attacks and flanking movements, while Soviet tanks fought as individuals rather than as coordinated units. These tactical and technical deficiencies meant that despite the T-34's superior armor and firepower, German forces consistently achieved higher kill ratios in tank combat throughout 1941 and 1942. The Soviets compensated through sheer numbers and willingness to accept catastrophic casualties. By early 1943, the T-34's advantages were eroding as Germany fielded new weapons specifically designed to counter it. The long-barreled Panzer IV with a high-velocity 75mm gun could penetrate T-34 armor from the front at normal combat ranges. New German anti-tank guns like the PAK-40 could destroy T-34s from 1,000 meters. German tank crews had learned T-34 weak points and tactics to defeat them. Most concerning for Soviet military planners, Germany was developing entirely new tank designs specifically to dominate the T-34. Reports reached Moscow about a new German heavy tank called the Tiger and a new medium tank called the Panther. Soviet intelligence indicated the Panther was being designed explicitly to combine the T-34's sloped armor concept with superior German engineering and firepower. The Panther would enter combat at Kursk in July 1943, and the encounter would test whether German engineering excellence could overcome Soviet production capacity and battlefield experience. The Panther medium tank was Germany's response to the T-34 shock. When German forces first encountered T-34s in 1941, German military leadership demanded a tank that could match or exceed T-34 capabilities. A German commission examined captured T-34s and recommended simply copying the Soviet design with minor improvements. German engineers rejected this approach as beneath German engineering standards and instead designed an entirely new tank incorporating T-34 concepts while exceeding it in every measurable category. The result was the Panzerkampfwagen 5 Panther, a tank that on paper was superior to the T-34 in armor, firepower, optics, crew ergonomics, and fire control systems. The Panther was also vastly more expensive, complex, and difficult to produce than the T-34, requiring skilled labor and precision manufacturing that Germany's war economy increasingly could not provide. The Panther's design specifications demonstrated German engineering at its most ambitious and most problematic. The tank weighed 45 tons, nearly twice the T-34's weight, but incorporated T-34-style sloped armor for maximum protection. The frontal hull armor was 80 mm thick set at 55-degree angles, providing effective protection equivalent to over 140 mm of vertical armor. The turret front was 100 mm thick. The side armor was 40 mm, thinner than ideal but necessary to keep weight manageable. The main armament was a 75 mm KWK-42 L-70 gun, one of the most effective tank guns of World War II, capable of penetrating 100 mm of armor at 1,000 meters. This meant the Panther could destroy T-34s from ranges where T-34 guns could not penetrate Panther armor. The optics were superb, giving Panther crews superior target acquisition and firing accuracy compared to Soviet tanks. The engine was a Maybach HL230 gasoline engine producing 700 horsepower, giving adequate power for the Panther's heavy weight. Every aspect of the Panther was engineered to be superior to the T-34, and in terms of pure combat performance, it succeeded. The problem was that Germany could not produce Panthers in sufficient numbers to matter strategically. German industry struggled to manufacture Panthers at the scale required. The complex sloped armor required precise cutting and welding that could only be performed by skilled workers. The transmission and final drives were stressed beyond design limits by the tank's weight and frequently failed after minimal use. The interleaved road wheel design provided excellent cross-country performance, but was prone to jamming with mud and debris, particularly in winter conditions, when mud froze between the wheels and immobilized the tank completely. Early Panthers rushed into combat at Kursk in July 1943 suffered catastrophic mechanical failure rates. Of the 200 Panthers deployed, fewer than 40 were operational at any given time during the battle. Many Panthers broke down before reaching combat. Some caught fire due to engine problems. Others threw tracks or suffered transmission failures. German commanders had wanted to delay the Kursk offensive until Panthers were mechanically reliable. But Hitler insisted on attacking before Soviet defenses became stronger. The result was a mechanical disaster that demonstrated the fundamental problem with German tank design philosophy. Engineering excellence meant nothing if the tanks could not reach the battlefield or stay operational once there. When Panthers did function properly, their combat performance was devastating to Soviet armor. The 75 mm gun could destroy T-34s from 2,000 meters, well beyond the effective range of Soviet tank guns. Panther crews reported killing 5 or 6 T-34s before the Soviet tanks could close to effective firing range. The sloped frontal armor was effectively immune to T-34 76 mm guns at all but point-blank range, forcing Soviet tank crews into desperate close-range attacks where German defensive fire would destroy most attackers before they could get shots on target. Individual Panthers positioned in defensive positions could hold off entire Soviet tank battalions for hours. One Panther commander, Ernst Barkmann, destroyed over 80 Soviet tanks during his combat career, most while commanding Panthers. These exceptional performance statistics demonstrate what the Panther was capable of when it worked. The problem was reliability. A Panther that broke down on the road to the battlefield was useless regardless of its superior combat capabilities. The Panther's greatest strategic failure was that it arrived too late and in insufficient numbers to affect the war's outcome. Germany produced approximately 6,000 Panthers between 1943 and 1945. Impressive by German standards, but insignificant compared to 84,000 T-34s produced during the same period. For every Panther on the Eastern Front, there were 15 T-34s. German tank crews knew they were individually superior, but strategically overwhelmed. Soviet commanders accepted that attacking Panthers would cost 3 or 4 T-34s per Panther destroyed, and considered this an acceptable exchange because replacement T-34s were always available while destroyed Panthers could not be replaced quickly enough. The mathematics of attrition warfare favored Soviet production capacity over German engineering quality. Panthers won tactical engagements, but lost the strategic war because there were never enough of them, and they spent too much time broken down in repair facilities rather than fighting on the front lines. The Panther also suffered from Germany's deteriorating strategic situation. By late 1943, Germany was losing the war on all fronts and could not provide adequate supplies, fuel, or spare parts to Panther units. Many Panthers were abandoned not because they were destroyed in combat, but because they ran out of fuel or broke down and could not be repaired before Soviet forces advanced. German retreat from Soviet territory in 1943 and 1944 meant abandoning hundreds of Panthers that could have been repaired if Germany had held the territory. The Panther's mechanical complexity became a critical vulnerability when operating in a deteriorating logistical environment. Soviet T-34s were crude and basic, but could be repaired in field conditions with minimal tools. Panthers required specialized equipment and trained mechanics that became increasingly unavailable as Germany lost ground and resources. The engineering that made the Panther superior in combat made it inferior in sustained operations under adverse conditions. The Battle of Kursk in July 1943 was the decisive test of Panther versus T-34. Germany committed nearly 200 Panthers to the offensive alongside Tiger heavy tanks and conventional panzers. The Soviets deployed over 3,000 tanks, including approximately 2,000 T-34s in defensive positions across multiple fortified lines. German planners expected the Panthers' superior firepower and armor to break through Soviet defenses in a decisive offensive that would regain the initiative on the Eastern Front. Instead, the battle demonstrated that mechanical reliability and numerical superiority mattered more than individual tank performance. The Panthers that reached combat performed well, destroying Soviet tanks at impressive ratios. But most Panthers never reached combat effectiveness due to mechanical failures. Meanwhile, T-34s continued fighting despite losses. Because Soviet factories could replace destroyed tanks faster than German forces could destroy them. The raw numbers explain why Germany lost Kursk despite fielding superior tanks. On the first day of the offensive, approximately 200 Panthers were deployed. Mechanical failures reduced this to fewer than 40 operational Panthers within 24 hours. By the third day, fewer than 20 Panthers remained operational. German mechanics worked frantically to repair broken Panthers, but as soon as tanks were repaired and returned to combat, other Panthers broke down. The operational readiness rate never exceeded 30% during the entire battle. Meanwhile, Soviet forces lost hundreds of T-34s to German fire, but replaced them within days from reserve formations and factory production. For every T-34 destroyed, 2 more appeared. For every Panther repaired, another broke down. The mathematics were impossible. Germany needed each Panther to destroy 10 or 15 T-34s to offset the numerical disadvantage. Even the most successful Panther crews could not maintain that kill ratio over sustained combat. Soviet tactics evolved to counter the Panthers' advantages. Rather than engaging Panthers in long-range duels where German optics and guns were superior, Soviet commanders ordered mass attacks at close range, where T-34 guns could penetrate Panther side armor. Soviet infantry advanced with anti-tank weapons to disable Panthers that had stopped due to mechanical problems. Soviet artillery targeted suspected Panther positions with massive bombardments to destroy or suppress the tanks. Fighter bombers attacked Panthers from the air, where the roof armor was thinnest. These combined arms tactics reduced the Panther's effectiveness by denying it the long-range engagements where it was most dangerous. The Soviets accepted horrific tank losses in close-range attacks, but had the industrial capacity to absorb those losses. Germany did not. Every Panther destroyed or disabled was a significant loss that could not be quickly replaced. Soviet commanders could lose 50 T-34s, destroying 5 Panthers, and consider it a strategic victory, because the replacement rate favored Soviet industry over German production. The crew survivability comparison favored neither tank significantly. When a Panther was penetrated, the larger internal volume and better crew layout gave German tankers slightly better survival odds than T-34 crews. However, Panthers were penetrated less frequently due to superior armor, so Panther crews overall had better survival rates. When T-34s were hit, the cramped interior and ammunition storage throughout the hull meant crew casualties were typically severe. Soviet tank forces accepted this as unavoidable and focused on training replacement crews, rather than redesigning the tank for better survivability. Soviet military doctrine emphasized the collective over the individual, and this extended to tank crews. Losing a tank and its crew was regrettable but acceptable if it contributed to destroying German armor. This ruthless calculation was possible only because Soviet training centers could produce replacement crews faster than T-34s were lost in combat. Germany could not replace experienced Panther crews as quickly, so the loss of trained personnel became as significant as the loss of tanks themselves. The final verdict of Kursk was that engineering superiority, without numerical superiority and mechanical reliability, was insufficient for victory. The Panther was the better tank in almost every measurable category. The T-34 won because there were always more T-34s, and they could keep fighting, while Panthers sat broken down, awaiting repair. German forces at Kursk destroyed Soviet armor at impressive ratios, but could not achieve the decisive breakthrough that would justify the offensive. The Soviet defense held, the German advance stalled, and Germany never again launched a major offensive on the Eastern Front. The strategic initiative passed permanently to Soviet forces, who would drive steadily westward toward Berlin for the next 2 years. The Panthers' combat debut at Kursk was a tactical success and a strategic failure, demonstrating that wars are won by industrial systems and logistical endurance, rather than by individual weapons performance. The T-34 won the Eastern Front, not because it was better engineered than the Panther, but because it was better suited to total war. Soviet factories could produce 3 T-34s in the time required to build 1 Panther. Soviet mechanics could repair a T-34 in hours with basic tools, while Panther repairs required days and specialized equipment. Soviet tank crews could be trained to operate T-34s in weeks, while Panther crews needed months of instruction. The T-34's crudeness was its strength. Every design choice prioritized production speed, operational simplicity, and field repairability over performance optimization. The result was a tank that was good enough to fight effectively while being cheap enough and simple enough to build in overwhelming numbers. This was the correct design philosophy for the type of war being fought on the Eastern Front. The production statistics tell the complete story. Soviet industry built 84,000 T-34s between 1940 and 1945. Germany built 6,000 Panthers between 1943 and 1945. For every Panther, there were 14 T-34s. Soviet factories operated continuously, with workers putting in 12-hour shifts 7 days per week. Entire cities were dedicated to tank production, with workers living in factory housing and eating in factory canteens. Soviet leadership accepted that production must continue regardless of cost in human suffering. German factories operated under similar pressure, but could not match Soviet output. Because Panther production required precision manufacturing that limited how fast production could be scaled. Soviet T-34 production required only industrial capacity and raw determination. The mathematics meant Germany was always losing the attrition war regardless of how well individual Panthers performed in combat. The operational reliability gap widened as the war continued. Early Panthers were mechanical disasters. Later models improved but never achieved the reliability of the simpler T-34 design. Panther units typically had 50 to 60% of their tanks operational at any time. The rest were in repair or awaiting parts. T-34 units maintained 80 to 90% operational readiness because repairs could be performed by crew members in field conditions without factory support. This operational gap meant that in practice, T-34 numerical superiority was even greater than production numbers suggested. If Germany had 100 Panthers in a sector, only 50 to 60 were operational. If the Soviets had 500 T-34s in the same sector, 400 to 450 were operational. The effective force ratio was 8 or 9 operational T-34s for every operational Panther. No amount of superior engineering could overcome that numerical disadvantage. Soviet forces learned and adapted, while German forces became increasingly rigid and doctrinaire. By 1944, Soviet tank commanders had developed effective tactics to counter Panthers. They used reconnaissance to locate Panthers, then called artillery and airstrikes to destroy or suppress them before committing tanks. They attacked at night or in poor weather when Panther optical advantages were reduced. They focused on destroying Panther support elements like fuel trucks and ammunition vehicles, immobilizing Panthers through logistics rather than direct combat. They trained specialized anti-tank teams to hunt immobilized Panthers that had broken down during movement. These adaptive tactics reflected a military organization that learned from experience and modified doctrine based on battlefield results. German forces increasingly relied on rigid defensive tactics that played to the Panthers' strengths in static defensive positions, but became predictable and could be countered through Soviet numerical superiority and artillery support. The Panther's legacy is that it represented German military thinking at its most problematic. German engineers designed superb weapons that were too complex to produce in adequate numbers, too difficult to maintain in field conditions, and too specialized for the total war environment, where adaptability and mass production mattered more than individual technical superiority. The T-34's legacy is that it was the right weapon for the war that was actually being fought, rather than the war German planners wished they were fighting. Soviet leadership understood that winning required accepting higher casualties and producing adequate weapons in overwhelming numbers, rather than producing perfect weapons in limited quantities. This was a brutal calculation that reflected the Soviet system's willingness to sacrifice individuals for collective goals. The Eastern Front was decided by industrial capacity, logistical sustainability, and numerical superiority. The Panther was individually superior. The T-34 won the war. The tank battle that decided the Eastern Front was not won by the tank with better armor or better guns or better optics. It was won by the tank that could be produced faster, repaired easier, and replaced more quickly. The Panther was a magnificent machine. The T-34 was an adequate machine produced in unstoppable numbers. History remembers the T-34 as the tank that broke the Wehrmacht and drove to Berlin. The Panther is remembered as might have been, the weapon that arrived too late, broke down too often, and existed in too few numbers to change the war's outcome. The lesson is that engineering excellence without industrial capacity and operational reliability loses to adequate engineering with overwhelming production and brutal determination. That is the final verdict of Panther versus T-34. If you found this comparison valuable, Subscribe for more tank analysis and Eastern Front history. Comment below, would you rather command a Panther with superior firepower but constant mechanical problems, or a T-34 that's crude but reliable with unlimited replacements? The debate continues.